Okay guys, I've had a few requests about the Microsoft form we did with minimum cuts and some people having issues and me wanting to go through these examples. That's fine, maybe I didn't explain it in the original video, but once you get your hand around it, it is a relatively straightforward concept. Now before we start, we're going to go through some language, okay? You have to understand this concept. The minimum cut. The cut is the line that we place through the network, okay? We're putting cuts through the network, through the different edges, okay? Putting cuts through the network and we're seeing, okay, cuts through the network and we're seeing what they add to. Note, a cut must separate the source from the sink. As we're exploring the flow from the source to the sink, if our cut doesn't separate the source from the sink, it's not valid. And that also goes for edges that go the wrong way. If our edge and the direction of the flow is not going from source to sink, that's not a valid cut. Now, what we want to do is, when we draw our cuts, we want to shade the source side of our sink, because we're only really concerned with the flow from the source to the sink. So this helps me see, is my edge going from the shaded side to the unshaded side, from the source to the sink, and then it becomes valid. Okay, with these cuts, there's no rhyme or reason to where I put them. Okay, I'm just cutting the network and just seeing, okay, what's my minimum cut. The minimum cut though is actually equivalent to the maximum flow, because with the minimum cut we're finding the restriction in the network. We're finding, okay, where do we have a bottleneck, or where do we have a restriction? Because the minimum cut is actually going to tell us the maximum flow. So if we're asked find the minimum cut or find the maximum flow, they're asking for exactly the same thing. They're finding, okay, what's the most I can get through the network, and where is the restriction? And with these cuts, that's what we're going to find out. Now, 9, 8, 17 plus another 6 is 23. Okay, that's my value of my first cut. 4, 10, 14, 21, 29, 32. Okay, so I'm looking for the smallest one possible. I'm looking for the minimum one, so it's not going to be 32. Okay, I look at this one, this cut down here, and I'm going source to sink. I'm going to count 10. 4 is actually going the wrong way, so I'm not going to count it. Plus 10 is 20, 27, 35, 38. Okay, already that's not the minimum one, that's not the smallest one. Next one, 4, that's going the right way, source to sink. This 4 is going the wrong way, I don't count it. 6 is 10, 15. Oh no, that is going the right way. That is going the right way, so we do count the 4. 4, 4, 14, 19, 22. And then 10, 9, and 6, 10, 6, and 9, we get to 25. So it's not going to be that one. Okay, this value is equal to our minimum cut, which is also our maximum flow. Okay, they're the same thing. We've found the max flow we can get through the network is 22. Now you might be looking at that and going, sir, where do I put the lines? Okay, that's the thing. Okay, what we're trying to do is we're trying to randomly place these cuts through the network and explore. Okay, so there's no rhyme or reason to where we put it. As a general rule though, you should be looking at the smallest edges in your network and trying to cut through them, because that's going to give us our minimum cut, our lowest number. Now, if you wanted to, I'll come back to this one later and show you how to do it another way to check your answer, but we'll keep going with minimum cuts.
I've still got it down. Okay, once again, I've put cuts through my network. I'll shade the source side because I'm only concerned with the flow from source to sink. And I'm looking to find the lowest number. So logically, you think I'm trying to avoid these big edges. Like my minimum cut is not going to go through 250 when it can go through 125. Okay, it's not going to go through 200 or 145 when it can go through 100. But we'll show you. 125 plus 320 is 445. And then we go 445, we get up to 590. 125 plus 320 plus 100, that's 545. So we can disregard that one. And 250, 320, we're already getting pretty close. And that we know it's not going to be that one because that's 550. We're getting up to 770. So what's this number? This is our minimum cut, which is our maximum flow. This edge here shows the limitations in the network. Okay, we've found the limitations. The most we can ever get through this network in an hourly period or whatever is 445. We've found the restriction. Okay, this one we're being asked to find the capacity of cut A. So we'll go ahead and do that. Now we'll shade source side, okay, which is our reservoir, because we only want to explore the edges that go source to sink. So
source to sink, we'll count that one. We won't count the 21 because it's going sink to source, it's going the wrong way. We'll cut this 29 though, and we'll count this 37. 19 plus 29 is 48. 48 plus 37, we're up to 85. So this is the value of the cut. It might not be the minimum cut in my network, but all we're being asked is what's the value of cut A. Okay, this one is about as hard as they get. But what we should be doing, once again, for a cut to be valid, we want to separate the source from the sink. So something like that isn't going to be a valid cut because I can still get flow around the top. Okay, when we get to this size, we should be looking through the network and going, okay, I want to go through the smallest edges possible, the smallest weight. For example, if I do this cut, through 13, 14, and 9, okay, I'm looking at pretty big values. But if you look up here, you know, through the 12, I'm not going to go through the 5 when I can go through a 3. Okay, I'm not going to go through 4 and a 5 because that's going to add to 9. I might go through this 7. And then we get to 22, which is not bad. Okay, another one I could do is if I look up here, I could go through this 5 and I could go through this 5. Okay, I've got the choice. I can cut through these two edges, but that's going to cost me 9. Remember, I'm looking for the lowest number possible. Why would I cut through a 9 when I can cut through a 3? And that 3 is going the wrong direction as well, so I won't even count it. Then I could finish down in this 12, but that's going to add 12 to my cut. Why would I add 12 when I'm looking for the lowest number possible? This 3 is going the wrong way, and this 5 is going the right way. So I'm trying to get the lowest number possible. Just make sure I shade the source side so I know which ones to count. So this way, I get 5, I'll count that. 5, I'll count that. 3, I won't count because it's going the wrong way. It's going from sink to source, so I don't count it. 3 is also going the wrong way, and 5, so I get to 15. Okay, I can keep going and look at other ways, but I don't think I'm going to get smaller than 15. Okay, that is, once again, the minimum cut, which is our maximum flow. Okay, systematic approach. The most we can ever hope to get through this network is 15. Okay, let's have a look at these two. 35, we're going to find the cut A. 35 plus 21 plus 42. That gets us to 8. 3, 2, 9. We get 98. The next one, remember, these all are going the right way. They're all going from source to sink. This one's a little bit different because we've got 23. Okay, that's going source to sink. 26, 36, 16 is actually going the wrong way. It's going sinks to source, and 42. We add that up and we get 9, 15, 17. We put a 1, 3, 5, 8, and 12, and we get 127. So this question is just asking us the value of cut A and cut B. Now, the third bit, we want to know what's the max flow through the network. So we start doing some cuts. Now, you'll look, we want to go through the smallest edges possible. You know, I think, when you think about it, I've already done 2. I might want to go through this 18, but if I cut that 18, I've got to go through 26 and 36, which is more than this 28. Now, I can cut down here, but that's going through a 28 and a 50. So 28 and 50, I'm at 78. Not too bad because it's bigger than these two, so I might be in the ballpark. But if I keep going and I do this one, you'll notice okay, it's going through a 28. My 16 is actually going the wrong way, so I won't count it, and 42. 28 plus 42 is 70. Okay, that's my minimum cut. I want to be forced to go through this lowest edge. Okay, so what are we doing? We're finding the minimum cut, which is the max flow. The max flow I can hope to get this through this network is 70. Okay, they're the examples. Good luck, guys. I'll talk to you later.